Induction with division is more my speed, to be frank, because I know there's a lot of juggling around that we have with induction and inequalities. With division, with induction with division, you're actually going to see a lot of the same things that you've seen in previous and other types of induction problems that we've had before. This one's going to check to see if an equation is divisible by a particular number. Now, I'm going to be straight up honest with you on the next part here. On the examples that I saw from the book and some things that are online and from other books and stuff like that, I added one thing in there really for us programmers to hopefully it makes more sense. When we talk about divisible, I think of modulus. And when something is divisible by a certain number, we use modulus and see if that remainder is equal to 0. So while you'll see an example of this in your book, looks very similar to what I did, I'm adding the modulus equals 0 in the problem because of us programmers. And it really makes that, frankly, to me, a heck of a lot more sense, probably because I'm a programmer, okay? I'm hoping it works out for you. But when you're looking at other sources or the book itself, you're going to see I did one extra step to that, just again, because we're used to being programming. You're still building the K plus 1, but the interesting part is that you're getting it into a certain form. You're going to see this happen twice. In the two examples I'm about to show you. So it's really interesting because what you're going to have is you're going to basically break up the equation into two parts. One part is an item using the base case that you already know that's going to be divisible, and that's going to be on the left-hand side. Whatever that equation is going to match what we are given in the problem. And then, by no magic at all, what you're going to have is you're going to try to get to a multiplier that matches that divisible, because frankly it says, well, 3 times whatever this is, that means it can be divided by 3, and we get a remainder of 0. And that's this bottom part right here. So you're going to see the form of this equation get us into this inductive hypothesis saying that, look, one part is divisible by 3 and the second part is divisible by 3, then the whole thing must be divisible by that particular number that we're looking for, which in this case is 3. Doesn't always have to be 3. Matter of fact, one of them is 57 here in a moment. But anyway, that's the form that we're going to try to manipulate our equations into, is this type of form in order to get basically a 2-for-1 shot in our overall proof. You've seen this before too. There's a build up and a build down to this. In the build up scheme, what you're going to have is you're not going to have a lot of meat on the bone, meaning the equation with K plus 1 doesn't give us much to finagle and get us to where we want in our overall form in order to do this. So we're going to start from the original equation, which is very similar to what we had before. We're going to add K plus 1, and then we're going to manipulate to get our modulus to work out. Then there is the build down, where you're given plenty on the bone. You add that K plus 1, you break it down using FOIL, multiplication, etc., and then you get that modulus to work as well. So you'll see both forms in this. And I bring it up in my examples here in a moment, but I wanted to show you both sides of this as well, that could be done. Let's put it that way.